Hello, everyone. My name is Todd McGrath. I'm a senior solution architect specializing in data streaming here at AWS. I have the honor of talking about analytics in 15 minutes with you all today, and we are going to be talking about building the world's largest games with data streaming. Let's begin by asking ourselves why. Why data streaming in the gaming industry? There are numerous challenges in the gaming industry, and as we think about these challenges from left to right, we'll start with something I'm sure is obvious. It's about scale, and it's about scaling to tens of millions of players from all over the world at the lowest possible cost. In doing so, we're going to be needing tools that are secure to process and analyzing petabytes of ever-changing data with extremely low latency requirements. This is in order to optimize the lifetime value of our players. Many of the gaming companies that we work with at AWS are in the process of migrating from an on-premises environment to AWS. This can often be difficult for gaming companies as they navigate the challenges, and it often leaves developers wondering where to even begin. Finally, we believe, as do many of our game company customers, that developers and others should be focused on building fun, innovative games versus spending time and effort handling infrastructure. Now, I've mentioned some gaming companies already, and I'll show you some more here on this slide. We are proud to serve over 90% of the world's biggest public game company on AWS. You'll see some of their logos here now, and I'll tell you in just a few slides, we're going to dive deeper into some of the data streaming that's happening at Riot Games, Epic Games, and Supercell. You might be wondering, how do gaming companies do it in AWS? How do they implement data streaming? Let's start with defining the anatomy of data streaming analytics. And in order to do so, in order to build data streaming architectures, which ingest, process, and analyze high volumes of high velocity data from a variety of different sources, I believe we need to consider 5 key components. As data continuously flows from left to right in this slide, you'll see we define the anatomy of streaming analytics starting with data sources on the left-hand side. This is devices and applications that are producing real-time data at a high velocity. Now, in order to accommodate that, we move to number 2 of 5 in stream ingestion. This can be ingesting from tens of thousands of data sources, and it needs to be collected in real time. Once it is collected, it needs a place to land, and this brings us to stream storage. We're going to deep dive into this and others later in this presentation, but for now, stream storage can be considered something that stores the event data in the order it was received and can be replayed. Once we have the streaming data in storage, we need a way to process that, and that comes to number 4, stream processing. You can think of stream processing as filtering, aggregating, joining different event data in order to create a curated result set. This is what enables real-time analytics, or often known as streaming ETL as well. Finally, the results, or this curated data, can often be sent further downstream into a destination like a data lake or warehouse, which are the most common. But we also see the destination being purpose-built databases as well as search indexes. Now, there's a couple of components of these 5 that I'd like to zoom in on because this is what makes data streaming unique. Let's focus on the items shown on your screen here: stream ingest, stream storage, and stream processing. Let's start with your options of streaming ingest in AWS. Now, this might seem like a lot of options, and it's true, there are a lot of options. And this isn't actually all your available options. But I'd like you to notice a pattern here. The patterns such as change data capture or custom building for things like microservice streaming, or even pre-built agents, which are continuously streaming. Some of the options include adding change data capture capabilities to DynamoDB, which might be your operational data store, or using Amazon Database Migration Service, or DMS, for change data capture use cases. Amazon MSK Connect is our managed Kafka Connect offering, which allows a variety of different use cases, such as ingesting from files, change data capture from databases. As I mentioned, you can write custom producers using stream storage specific software development kits and client libraries. We also include the ability to deploy pre-built agents. And for those of you that are in IoT related gaming, AWS IoT Core might be an option as well. After ingest, you might recall that it's stream storage. And when it comes to AWS options, the two most popular are Amazon Managed Streaming for Apache Kafka, or commonly referred to as MSK, as well as Amazon Kinesis Data Streams. Now, both of these stream storage options are often misconstrued as just another message bus. But there are some key characteristics that make these two stream storage services different than traditional message queue. One, these stream storage services store data in the order it was produced. Two, the data that's stored for a certain amount of time can be replayed. And three, these are highly scalable options for stream storage. Next up, we have stream processing in AWS. This is the transformation layer, or the ability to filter, aggregate, create results from multiple streams of data as it is arriving in stream storage. Some of the examples of stream processing in AWS are shown on the screen. At the very top, we have Amazon Kinesis Data Analytics for Apache Flink. In addition, we have something known as KDA Studio. Both of these work well with the previously mentioned stream storage options of Amazon MSK and Kinesis Data Streams. On the other side of the stream storage, like the front side, we can use MSK Connect as well. This allows lightweight transformations and sending of the data to downstream destinations. Similar to MSK Connect, we have Amazon Kinesis Data Firehose that allows the consumption from stream storage, such as Kinesis Data Streams and many more, performing lightweight transformations again and sending that data downstream. If we keep going, we have AWS Lambda, which is a serverless offering for creating these real-time transformations as they are landing in Kinesis Data Streams or MSK. Finally, to wrap things out for options on AWS, we have Amazon EMR, which includes a couple of different stream processing implementations, such as Spark Streaming, as well as Apache Flink. AWS Glue allows our users to create Spark streaming applications. And finally, similar to the streaming ingest side, we have the ability to build custom consumers using stream storage specific SDKs and client libraries. To recap, when building streaming applications, the anatomy consists of 5 key components. We deep dive into 3 of these: stream ingestion, stream storage, and stream processing. To wrap up this section, let's talk about why this matters on AWS. Streaming data analytics on AWS is easy to use. It provides elasticity, which means scaling up, scaling down, scaling out, and scaling back in. It's highly available and durable. It allows for seamless AWS integrations. It's fully managed, and as you would expect, you pay for what you use. What about some of the success stories in gaming? Let's take a few of those now. And I mentioned we'll deep dive on some of the logos that we saw earlier in this presentation. Let's start with Finland-based Supercell. Founded in 2010 by 6 game industry veterans, Supercell is one of the fastest growing social game companies in the world. With more than 100 employees, its 3 games are massively successful, attracting tens of millions of players on iOS as well as Android devices. These games include Heyday, a social farming game, and Clash of Titans, as well as Boom Beach, which combine social resource management and strategic combat elements. The challenge for Supercell included a way of handling over 45 billion events per day. They chose Amazon Kinesis data streams for this implementation. And whereas they recently ran their own Hadoop instances on Amazon EC2, Supercell is now using Amazon EMR, which was mentioned previously. The benefits for Supercell include the ability to evolve and improve by analyzing the data from their users over time. Next up, we have Epic Games. Epic Games is the interactive entertainment company behind Fortnite. This is one of the world's most popular video games with over 400 million players. Founded in 1991, Epic transformed gaming with the release of Unreal Engine, the 3D creation engine powering hundreds of games now used across industries such as automotive, film, and television. One of the challenges faced at Epic Games was at Fortnite and being able to serve over 15 million concurrent players during live events. The Epic solution on AWS processes and stores petabytes of data in an AWS data lake. It then uses AWS Analytics to assess player sentiment and inform the development of unique experiences. Again, this is similar to the previous gaming use case at Supercell, allowing the data to be used to improve and provide unique experiences for their players. Next up in gaming success stories is Riot Games. And let's look more closely at this success story. Based in Los Angeles, California, Riot Games is a video game developer and publisher renowned for creating one of the world's most played PC games, League of Legends. While Riot's growth started with League of Legends, and with its success allowed Riot Games to expand into additional games, services, and even new industries such as esports. As Riot Games grew, so did their data streaming and analytics challenges. In July 2022, Riot Games announced they were going all in on AWS, focused on powering Riot's infrastructure, including their new global content factories that publish Riot's esports, music production, analytics, statistics, and animation. Other possible workloads include leveraging AWS instances to create a future slate of cloud-based, on-demand, and live content, and to use AWS to power the build-out of Riot's cloud-first production facilities based in Dublin, APAC, and Seattle. Now, one of the things that I wanted to call out with Riot is as they grew, they implemented AWS services in a step-by-step approach, as shown on this slide. This evolution continues today. Now, the details of this evolution aren't as important as the key takeaway here, and that is gaming companies such as Riot have the ability to build on and utilize AWS services in phases, which offers the benefit of focusing on outcomes such as improved game experience for users and performance and cost optimization over time. Further resources on Riot will be explored shortly. Speaking of resources, at this point, you might be wondering, what are some of the resources available to you? Let's start off. One of the resources is picking up where we last left off, Riot Games. Most recently, a presentation was given that highlights how Riot Games processes over 20 terabytes of analytics data daily. This presentation was at reInvent 2022 just a few weeks ago and was presented by both representatives from Riot Games as well as AWS. A little bit about this presentation includes data at Riot was only queryable up to 6 hours after it was produced. However, with Amazon MSK, the team reduced time down to 5 minutes. Amazon MSK allowed Riot Games to lower TCO and deprecate an aging MapReduce-based pipeline. In this session, Riot Games describes the before state, migration path, current state, and future state of their data ingestion pipeline. Next up in resources is the Game Analytics Pipeline, which is a customer deployable reference architecture provided by AWS to help game developers ingest, store, and analyze telemetry data from games and services. The guidance supports streaming ingestion of data, allowing users to gain insights from their games and other applications within minutes. It provides a REST API and Amazon Kinesis services for ingesting and processing game telemetry. Source code is provided. Next up, we have a best practices white paper. As we now know, many customers run their digital games on AWS. Each of them has made unique design choices that allow them to run the fastest, most complex, and visually breathtaking games on AWS. This white paper outlines best practices for building a data lake for games on the AWS cloud and offers a reference architecture to guide organizations in the delivery of these complex systems. Finally, for resources and as part of the well-architected framework data lens, we have the streaming ingest and stream processing scenario. This reference scenario real-time streaming data requirements throughout scalability, reliability, high availability, and low latency to support a variety of applications and workloads, including gaming. It is built using the five core constructs we explored in this presentation earlier. That is data sources, stream ingestion, stream storage, stream processing, and finally, destinations. Thank you so much for joining me on this presentation. I hope it was my pleasure to deliver this to you, and I hope you found it valuable. Thank you very much.